Hey everyone and welcome! If you're getting ready for the CUET, you are in exactly the right place. Today, we're jumping into a chapter that can give your organic chemistry score a serious boost, amines. Trust me, this is one of those topics where just a little bit of understanding goes a very long way. So, let's get right into it. Alright, let's kick things off with a classic CUET-style challenge. Take a look at this question. Why is aniline, the one with the big benzene ring, a weaker base than simple ethylamine? I mean, they both have a nitrogen with a lone pair of electrons, right? So what's the deal? If you can confidently explain this right now, you're already ahead of the game. But hey, if you're a little unsure, do not worry. By the end of this question is going to feel like a piece of cake.
So why are we focusing so much on this one question? Because it's not just about one question. Understanding this single concept is the key to unlocking the answers for at least 3 different types of MCQs that you're definitely going to see on the CUET exam. Questions on basicity order, those tricky assertion-reason problems, and even questions where you have to predict reaction outcomes. The takeaway here is huge. Master this, and you're not just grabbing 1 mark, you're securing a whole section of your paper.
So, what is the big secret behind why amines act as bases? Well, it all comes down to one tiny but super important thing. That lone pair of electrons sitting on the nitrogen atom. Let's break that down right now. First things first, a super quick refresher. What exactly are amines? Just picture the ammonia molecule, NH3. Now imagine you can just pop off 1, 2, or even all 3 of those hydrogen atoms and snap on a carbon group in their place. This could be a straight carbon chain, which we call an alkyl group, or it could be a benzene ring, an aryl group. That new molecule you just made? Yep, that's an amine. And here is where the magic really happens. A nitrogen atom has 5 valence electrons. 3 of them get busy forming bonds with other atoms, but that leaves 2 electrons, a lone pair, just sitting there on the nitrogen, available. This available pair of electrons is basically a gift that the nitrogen can donate to a proton. And in the world of chemistry, the ability to donate an electron pair is literally the definition of a base. So remember this, that lone pair is everything.
Now, to really get a grip on amines, we've got to know how they're sorted. Think of it like cracking a code. There are 2 main ways we classify them, and you can bet the CUT loves to test you on both.
Okay, the first method is super straightforward. You just count how many carbon groups are directly bonded to the nitrogen atom. If there's 1 carbon group, it's a primary amine. 2 carbon groups, it's secondary. And if there are 3, you got it, it's tertiary. Now listen up, because this is a massive exam trap. A lot of students make the mistake of counting the hydrogens. Don't do it. Your focus has to be only on the number of carbons attached directly to the nitrogen. Do not fall for that trap.
The second way we classify them is all about the type of group attached to the nitrogen. Is the nitrogen hooked up to a carbon chain? That's an aliphatic amine. Or is it bonded directly to a benzene ring? That's an aromatic amine. And right here, this is the very heart of the puzzle we started with. Think of it like this. The carbon chains or alkyl groups are generous. They push electron density onto the nitrogen, making that lone pair even more available to be donated. That means it's more basic. The benzene ring, on the other hand, is kind of selfish. It pulls that lone pair into the ring through a process called resonance, spreading it out and making it way less available, and that means it's less basic.
Let's take a quick look at the structure, another favorite topic for exams. The nitrogen atom in an amine is sp3 hybridized. And because it has 3 bonds and 1 lone pair, its geometry is something called trigonal pyramidal. You can picture that lone pair as a big puffy cloud of electrons that takes up a lot of space, and it actually pushes the bonds closer together, squeezing the bond angle down to about 107 degrees. Very important, the shape is trigonal pyramidal, not tetrahedral. That's a classic mistake students make. Okay, we've gathered all our clues. We know about classification, electron effects, and structure. It's time to go back and finally solve the puzzle we started with. Ring versus chain. Let's settle this once and for all.
So here we are, the final showdown. In the battle for basicity, who's going to come out on top? The amine with the carbon chain or the amine with the benzene ring? What do you think?
And the winner is ethylamine. The chain wins hands down. And why? It's because its alkyl group is an electron-donating group. It pushes electron density towards the nitrogen, which makes that lone pair super available for donation. Aniline, on the other hand, is weaker because that big benzene ring pulls the lone pair into its resonance system, spreading it all over the ring and making it much, much less available to act as a base.
Now, understanding a concept is one thing, but being able to recall it under the pressure of an exam, that's a whole different ballgame. So let's move on to some unforgettable memory hacks that are going to lock this knowledge in your brain for CUET.
Here's the most important one you need to remember. It's a simple little phrase. Ring steals, chain heals. The benzene ring steals the lone pair through resonance, making it less basic. The alkyl chain heals the nitrogen by pushing electrons towards it, making it more basic. Say it out loud with me. Ring steals, chain heals.
Let's give you a couple more weapons for your arsenal. For classification, just think 1, 2, 3, count the carbons for me. It's a simple way to remind yourself to always ignore the hydrogens. And for the shape, remember this one. 3 bonds and 1 lone pair make a pyramid chair. It's a really quick way to remember that trigonal pyramidal geometry and not get tricked by that tetrahedral option.
Okay, I need your full attention right now. These are the mega traps, the places where students constantly lose easy marks on the CUET. Trap number 1, thinking tertiary amines are always the strongest base. This is only true in the gas phase. In water, other factors come into play, and secondary amines are often stronger. Trap 2, forgetting that resonance is a thing and aromatic amines. Trap 3, confusing the trigonal pyramidal shape with tetrahedral. Trap 4, classifying by counting hydrogens instead of carbons. And trap 5, ignoring the healing effect, that electron-donating nature of the alkyl groups. You need to burn these traps into your memory so you can easily sidestep them on exam day.
All right, theory's done. Now it's time to put your knowledge to the test with a rapid CUET-style practice round. I'm going to show you a question, and I want you to pause, solve it for yourself, and then hit play to check your answer. You ready? Let's do this.
Question 1. Which of these is the most basic compound? Your options are aniline, ammonia, ethylamine, or nitrobenzene. Pause the explainer now and lock in your answer. Okay, you got it? The correct answer is C, ethylamine. Why? It's our chain molecule. It has that helpful electron-donating group, which makes it the strongest base among these options.
Question 2 is a direct memory check. What is the hybridization of the nitrogen atom in amines? Your options are sp, sp squared, sp3, or dsp2. Pause and pick one. All right, the correct answer is C, sp3. This is just one of those fundamental facts about amines you have to know cold.
Question 3 really gets to the why. Aromatic amines are less basic primarily because of what? Is it the inductive effect, hyperconjugation, resonance, or steric effects? Pause and think about it. The answer is C, resonance. This is our ring steals principle in action. That ring pulls the lone pair away, which weakens the base. And for our last question, what is the shape of a simple amine molecule? Your main options here are tetrahedral or trigonal pyramidal. Pause now and make your choice. The correct answer is D, trigonal pyramidal. Remember the trap. It's not tetrahedral because that lone pair pushes the bonds down. Just like our mnemonic says, 3 bonds and 1 lone pair make a pyramid chair. Fantastic work on that quiz. Before we wrap up, let's lock it all in with a 30-second lightning revision. Ready? 1. Classification is based on the number of carbons attached to nitrogen. 2. Basicity. Chains beat rings. Aliphatic is stronger than aromatic. 3. Why? Rings have resonance, that's the ring steals. Chains have electron donation, that's the chain heals. 4. Hybridization is sp3. 5. The shape is trigonal pyramidal. And 6. The source of all of this basic character is that amazing lone pair. Got it? Awesome.
And that is a wrap. You have just successfully broken down one of the most important concepts in organic chemistry for your CUET exam. So how did you do in the practice round? Go ahead and drop your score out of 4 in the comments below. I really want to see how you did. If this explainer helped you and you want to keep crushing these key topics, make sure you're subscribed so you don't miss the next one. Awesome work today. Keep up the amazing prep, and I'll see you in the next one.